So this is preparation for exercise 9.3 on the circle. So it's looking at what sometimes gets called the general equation of a circle. It's on page 19 in your maths tables, and it gives you the equation and what the center is and how you calculate the radius, the formula for each of those. Also in this exercise, we're looking at points inside, outside, or on the circle. How would you figure out where the point is? Now, to refer back to your textbook here, so on the previous page, it goes through where the formula might come from, if you want to have a look at that. All right, let's just get down to business here. So here's an equation of a circle given here. How do I calculate the center and the radius? What you do is you take the coefficient of the x here, which is -4. I divide that by 2 and change the sign to get the x value for the center, which is 2, and similarly for the y value, which I will get 3. So the center is 2, 3. Then I use those two values to work out. So I've got the square of the radius length, which is the square root of g squared plus f squared minus c. So that means I'm going to be squaring -2 squared plus -3 squared, and then minus c would be -12. So square root of 25 is equal to 5. You want to practice that now because it's quite easy to make mistakes in the past, like forgetting to change the sign when you're putting in the center, forgetting to divide by 2, writing down the formula wrong from the tables, but plenty of practice, that error shouldn't be made. So here we're working backwards here. Now again, with practice, you know that the 4 is equal to -g and the -2 is equal to -f. So what you actually do here is you double the 4 to get the coefficient of x in your equation. Double that and change the sign. That'll give you -8. And double the -2 and change the sign. That will give you 4. And then to work out R, you get the formula from the maths tables. To work out C, R is equal to the square root of g squared plus f squared minus c. In this case, you know it's 5. You square both sides, fill in your values for g and f, and break it down. Eventually you get down to -5 there. Alternatively, you can go with method 1, but I think most of you would probably go with method 2. I think it's the best approach. Now for points inside or outside around the circle, you just basically, the handiest thing to do is, if the circle is in this format here, you sub in your x, y, whatever point you're given, and if it's less than the right hand side, it's inside. If it's equal to, it's on the circle, or if it's greater than, it's outside the circle. So there's an example done there. Have a quick look at that there, and investigate the point 5, 4 lies inside or outside around the circle. Now, to me now, the method used here is quite elaborate. I am pretty confident most of you will go with the option on the next page, which is as follows. You basically sub in 5, 4 into the equation. But that is subbing 5 in for x, everywhere x is, and 4 everywhere y is. We'll have a quick look here at what it should look like. So if the equation of a circle is in that form there, then it can be shown, blah, blah, blah. So they sub it in there. You get an answer of 12, which is greater than 0, so therefore it must be outside the circle. Now, I'm pretty sure, oh yeah, sorry, there's some examples done here. So the last thing we'll look at here. Now, investigate these points are inside or outside in the following circle. So again, you sub in the 7 -5, it's actually on the circle. Sub in 8 -6, you get 41 on the left-hand side, so therefore it's outside the circle. The last one's a bit trickier. Find the range of values of t. So what we do here is you again sub that in there. You end up with a quadratic inequality here. Now, how do we do quadratic inequalities? You get down as far as t plus 1 squared is less than 16. So from the way we do them is, we don't just square it like that, we go like this. You solve the equation t squared plus 2t minus 15 equals 0 after sorting this stuff out here. You factorize it, or use a quadratic formula if you want to work that out. And then we draw a sketch, and the range of values are between -5 and 3. That is where the output is less than 0 there. And I'm running out of time here, so therefore my answer is t -5 less than t less than 3.